morning. Good morning. Today we're going to be talking about DHCP. We're going to look at how to install and configure a typical DHCP server. Now, the last time we were, trying to understand DHCP, we talked about what DHCP is, and we also talked about the concept of zones and zone records. Right. I remember the last time we talked about DNS policies, and we also established what DNS is all about. Now, today we are going to focus on DHCP. What's DHCP, by the way? It's what the acronym. It's Dynamic Host Configuration Protocol. And how does that help us? What does it do? So basically, what the DHCP does is that it allows us to configure end devices hosts automatically from a central location. Let's just put it that way, right? And what we're going to be looking at basically is try to understand the concept of DHCP and understand how it works. Okay, we're going to talk about scopes. We're going to understand what the scope is, and we also going to look at how to create reservations in DHCP as well as options. All right, without wasting too much of time, we're just going to get started. Okay, so the concept of DHCP is just a way to assign IP configurations automatically to hosts. Now, the reason I brought the talk about DNS to DHCP is because in well-configured environments, your DHCP works hand in hand with DNS. Because think about this: if I'm going to configure a client or a host, somehow that information needs to be stored in a central place in case someone wants to reference that client device or that host. You have a computer by the name server one. That server one is tied to an IP address, right? Whenever that IP address changes, you want to make sure that server one is updated. So we're going to look at that concept to, DHCP assigning IP addresses and automatically updating that information in DNS. We're going to look at that too. Okay, now many client devices you have on the network requires configuration, and one of the ways you can configure your client is to do it manually, but that's labor intensive. Imagine you have 2,000 clients you need to configure. It means you have to manually go to every single client device and provide the IP configuration that is required, right? So, like we were saying, with DHCP, it allows us to configure our clients automatically, and also not just that. When we are deploying client software or operating system, mostly operating system, DHCP is one of the key tools that actually helps us with that. Like take for instance, I want to deploy Windows, let's say Windows 10 or Windows 11. You have 100 computers. I can manually go in and start installing Windows 11 manually. But if I have a deployment server, I can deploy the same operating system to all 100 computers at the same time. But one of the tools that I need to be able to make deployment work is the DHCP, because we need the client needs to be configured in some way so they can actually reach the server that holds the software that we need to deploy. So DHCP also helps with that. Okay. Now, the DHCP server depends heavily on Bootstrap. So Boot P is called Boot P. Now, Boot P, is an earlier protocol that was used back then. Back then when you had mainframes, or you had big computers, or you had, let me call them mainframe. You have mainframe computers, or you have and you have end terminal. Now, most of those end terminals don't have any operating system in them. They need to boot from the server. Now, boot P protocol allowed the end terminal configure them such a way that they can boot from the server, right? So they don't need to hold any operating system of their own. But so DHCP works, it works based on that same concept. Okay. Now, DHCP server has been something that has been around for quite a number of time now. The different versions of Windows Server, had DHCP. Okay. Um, so older versions of Windows Server has DHCP. I remember, back then when I first got introduced to Windows Server, I think one of the first server that I really really worked with was Windows Server 2008. Though I worked with Windows Server 2020, but I don't think I really did much. Just more like looking and just working with. That's NT. I think it was called NT Server back then. But 2008 server was when I really started working on Windows Server. 2008 server. And 2008 server had DHCP, so you could configure most of all this stuff on Windows Server. So most older Windows Server had this, and newer ones also have DHCP. It's an essential role. So, like we said before, it allows you as the admin to be able to distribute IP address across all your devices. Not just IP address, also you can push out custom configurations through the DHCP server. Okay, you can push that to devices, to just anything on the network that connects to the network. Now, in order for DHCP to actually work effectively, there are different components. Just like when you want to build a house, in order for you to build a house, there are different parts you need to build a house, so different component of the house. You have the foundation layer, and there are materials you need for that. You have the walls, what you need for the walls. You have what you need for the plaster. You have what you need for the roof and everything. So there are different parts and different stages and different components of your DHCP server. We're going to try to look at some of them today and just try to understand it. Now, to begin with, um, your DHCP server requires the server services. So that's the server component, and that's the part that we install. That's the part we're going to be installing today, and we're going to be configuring. Right. So the server service, it needs that server service. Then within the server service, it needs a scope. The scope is just simply the range of IP addresses that the DSP server is going to be handing out to the clients. Okay. Now, apart from the scope, we also have what we call the DSP options. The options are more like, let me put it now. Let me define options based on the function. The options are just what's it called? Are just add-ons or additional thing that you want your DHCP server to help you configure. Put it that way. Because primarily your DHCP server, we assign an IP address to the host or to the client. But what if you want the DHCP server to also tell the client what the DNS server address is, what the boot server address is, or how to get to the what's it called, the naming server, your DNS server, and other things like that. Naturally, DHCP server cannot do that, but with DHCP options, we can do that. So basically, what I would say options are is it allows us to expand the configuration information that the DHCP server can provide to the host. It allows us to expand it. Now, like I said, I'm defining based on the function, right? Based on what it does, I'm defining based on the function. Now, the database, of course, if you're going to be handing out addresses, there has to be a way you recollect who you've assigned an IP address to, and there has to be a way to know how much IPs you have left, to assign to. Because if you just start assigning IP address to hosts randomly, if you're not careful, you're gonna have duplicates. And when you have duplicate on the network, if two devices have the same IP address on the same network, the two of them can't communicate because both of them will be conflicting against each other, right? So the DSP database allows us to store the DSP configurations, right? And also it allows us to hold the IP address that we're going to be distributing, and we also keep track of what is being distributed through the database. Then your console, DSP console, is where we manage our DSP on Windows Server 20, on Windows Server basically. So DSP console is where we manage our DHCP server. Now, how do we deploy a DSP server? Now, last time we talked about DNS, right? And we said your DNS can either be a standalone server or can be Active Directory integrated, right? That's what we said about DNS. Now, but with DHCP for the most part is going to be a standalone server. It's going to stand by itself. It doesn't need anybody's help. So we say they operate independently, okay? And when you install DSP server, you have to configure it independently, configure it by itself, and tell it the scope and everything that it needs to function. Um, so in Windows Server, basically, DSCP is installed as a role, right? It's installed as a role, and you can add the DHCP server in on Windows Server through the add or remove roles and feature. So the add roles and feature option, that's how you can add your DHCP server. All right. Now later on, we're going to look at what if we have a lot of clients that requires IP and we need to use more than one DHCP server. There are several options that we can use for that. Example is split scope, but we're going to get to that much later. Now, briefly, how do you deploy Windows Server? How do you deploy DHCP server? I'm just going to run through this briefly. So, what you're going to do from your Windows Server console, uh, at your Server Manager console, you're going to click on Add Roles and Features. Then you're going to select this server. Select the server you want to install it on. You're going to click Next until you get to the rows. You're going to select the DHCP server row there and click next. It's going to ask you if you want to add if you want to add the features or that comes with DHCP. You just select yes for that. Once you've done that, you click next and it's just going to install your DHCP server. Now the thing is that once you're done installing DHCP server, there are a couple of things you can do. For a start, you see this is one feature that you have with Active Directory integrated zone. If you have an Active Directory, if you have Active Directory and domain controller set up, but if you actually have an Active Directory and what's it called? You have Active Directory set up and you already have a domain controller. Now, one of the security features of Active Directory is that once you install a new DHCP server and you add it to the domain, that DHCP server cannot assign IP address to clients. No, immediately it can't. Why? For security. Because if you allow it to assign IP address to clients immediately, it means that you can have a rogue, an intruder can install a rogue DHCP server on your network and be assigning IP to clients automatically. So, how do you make your DHCP server assign IP to clients in an Active Directory network? You have to authorize it. So once you're done installing the DHCP server, if you check if it's not authorized, if you try to set up a scope, you're going to see a red X beside the server, beside this server. You're going to see a red X, meaning that that DHCP server cannot issue out any IP address. Even if you configure the scope, it will not issue out any IP address because it has not been authorized within that zone. So think about this. You want to build a house in Brampton, for instance. You didn't bother to go and get permit from the local government or from the municipal government. You decide to start building your house. What's going to happen? They're going to come with their bulldozer and everything, and they will tear down your house because why? Number one, you don't have permit. You are not permitted to build a house there. So if you build a house there, you cannot live there. We'll not let you live there. We'll lock the place up. So that's what the authorization. That's what is all about. Okay. That's what the authorization is all about. I said you can, before you can, before you can, or before a DHCP server can issue IP address on a Windows network that has Active Directory, it has to be authorized. Authorizing the DHCP server is more or less like getting approval from Active Directory or domain controller that this DHCP server is valid and is legitimate. That's what it is. Okay, and how do you authorize a DHCP server? What you do once you open once Server Manager is open, you click on Tools, you go to DHCP. Then from DHCP, once it opens up the DHCP server, you're gonna right click on the DHCP server and click Authorize. Once you click on that, it's gonna go through Active Directory authorization. Sometimes they might ask you to enter your credential, the credential to validate uh, that you have the authority to authorize that DHCP server. Once all of that is done, your DHCP server is going to be authorized. Now, one of the ways you know if it's authorized or not, if you look at the DHCP server right there and you expand it, the IPv4 and the V6 section of your DHCP server, if it's red with an X, it means that it's not authorized. But if it's green with the arrow, no, with the check mark, it means it has been authorized. But if it's not green, if it's red with an X, it means that that DHCP server is not authorized. You need to authorize it first before you can use that DHCP server on that domain. The next thing is DHCP scope. Now, how do we create a scope? Or what's the scope? I told you a scope is a range of IP address that the DHCP server can issue out. Now, before you can actually before a DHCP server can issue out IP address, it needs a scope. Now, how do you create a scope? Now, the way we create a scope is simple. Once you log into once you open your DSP console, you have IPv4 and IPv6, right? It depends. You need to determine what scope you are creating. Are you creating scope for IP version 4, version 6? If it's for version 4, what you need to do is just right click on the IPv4 section of your DSP server and click on, create, and click on new scope. Once you click on that, it's going to ask you a few questions. It's going to take you through the wizard. It's going to ask you a few questions. You provide the questions. It's going to ask you for your DNS server and as well as any other server you want to include, right? Well, it's going to ask you for all of that. Once you provided all of that, automatically it's going to create a scope. Now, there are some key areas that I really want to talk on when it comes to scope creation. Now, those are IP reservation and exclusion. Now, one of the options you're gonna face or you're gonna receive when you're creating the scope is for you to enter IP exclusion list and IP reservation. What is exclusion list? What is reservation? Now, or what's the difference? Now, let's take for instance we have a range of IP address, and let's say we have an address in the 192.168 10.0 scope. So that's a network. So 10.0 is our network, and we have maybe 200 addresses within that scope I want to configure. So you're going to have 192.168, maybe 10.0 all the way to 10.199, right? Now, this is the thing. You can decide that, oh, I want to assign from 10.1 to 10.10 to all my servers, right? And I don't want DHCP to assign that address to anybody. What do I do? You have to create the exclusion list. So whatever IP range you include in the exclusion list, that IP range will not be assigned to any host by the DHCP. No. The DSP will skip those IP addresses whenever it's assigning an IP address. It's going to skip that IP address so that and so anything you have in the execution list will be skipped by the DHCP server. It will not be assigned to any device or any yeah. It will be assigned to any device when DHCP server is assigning IP address. That's for execution list. What about reservation? Reservation. If you create a DHCP reservation, what is going to happen is that now, just so you know, to create a reservation, you need to know the MAC address of the device you want to create a reservation for. For exclusion, you don't need to know anything. Just know the range of IP address you want to exclude, and that's it. But for reservation, you need to know the MAC address of the device you want to reserve the IP for. So, what is reservation? Now, take a look at this, for example. This princess over here, she found a boyfriend, and the boyfriend, or the guy, not really a boyfriend, but she found a guy that likes her. The guy likes her so much. And he asks her, "Hey, princess, where would you like to have dinner tomorrow?" Well, she said, "I would like to have dinner at, what's the name of this popular restaurant? Steakhouse." Princess, you're vegetarian, right? Okay. Where do you like to have dinner? What restaurant do you usually visit? Okay, let's assume you visit Bombay restaurant. Now, what the guy is gonna do? The guy's gonna pick up his phone and call Bombay restaurant. Hey, Bombay, I would like to reserve a table for two for tomorrow at 6 p.m. Now, what just happened? Tomorrow at 6 p.m. when you get to Bombay, you don't need to struggle for a seat or struggle for a chair. Once you get in, they just tell you, "Oh, that's your table over there." What do you do? You walk in and you sit down. You don't struggle for any seat. So when we create a reservation list with DHCP, what we are doing, what we are doing in essence is we are assigning a particular IP address to a host. We are telling DHCP server, "Hey, DHCP server, this IP address, please always assign that IP to this host." That is why you create reservation with MAC address. So you get the IP address that you want to reserve, then you map that IP address in the reservation to the MAC address. So every time that device requests an IP address, it will always get the same IP address. Now you can combine reservation with exclusion list. You can. Because think about this, you have a server, you want the server to always have a particular IP address, you can create that. You create a reservation list. Okay? So you're gonna encounter that when you create what's it called? You create your scope. Now, the other thing I want to talk about here is the scope options. Now, when you're creating the scope, you're gonna encounter this too. Oh, I want to create an option. Well, what kind of option can I create? Now, there are several types of options you can create, and where those options can be implemented. Now, remember when we talked about group policy. I think we talked about group policy earlier. When we talked about group policy, I told you I can create a group policy object and attach it to the root. And if I attach to the root, it's going to affect everyone that's under that root. Or I can take the same option and attach it to an OU, and it's only going to affect everything within that OU. The same thing with DSP options. When we create an option, like there are different options, you can create options for your DNS server, right? You can create options for your boot server. You can create options for your deployment server. You can create options for just about anything you want to create. Your default gateway you can also create that too. You can create your router address, which is your default gateway. So that's option 003, I believe. So there are several options you can create, but where where would that option be implemented? That is what we talk. That's what we talk. That's what we mean by the scope options. Now, there are two types of options you can create: scope option and server option. Now, what's the difference? Now, if I create a scope option, That option will only affect a scope. So let's assume I want to create 5 scopes on my DHCP server, on my DNS server. No, what am I saying DNS server? DHCP server. Now I create a scope option. That option will only be applied to a particular scope where I created that option on. Like I want to let's assume I want to tell the client the address for the time server. My NTP. Let's assume I have an NTP server, and I want to deploy that to the client. I want the client to know about the NTP server. If I create an option and attach it to a scope, that option becomes a scope option. So only devices that are within that subnet where of that scope will get that option. Don't worry, it's gonna be more. You're gonna understand this visually when you do it practically. The next one is server option. If I create an option and attach it to the server, the DHCP server itself, every single scope that I create on that server will get that option. Like same thing, NTP. So if I create NTP, if I create an option for my NTP server and I make it a server option, every scope that I create within that server, that option automatically will be added to that scope. But if I create an option and make it a scope option, that option will only affect the scope where I've attached it to. So any devices that falls within that subnet that gets an ID from this server will get that option. But if it's a server option, all the subnets, you know, basically a scope is actually a subnet. When you create a scope, you create it for a subnet. So every single subnet that the DHCP server will be assigning IP to, we get that option. If I create, like I said, if I create an NTP server option, I make it server option, every single devices in any scope that DHCP server is assigning IP to will get that option. Okay, so moving away from that, let's look at different options. The most popular one, you have option 3, that's 003. 003 is router ID, that's the same thing as your gateway. Okay. Now 006 is DNS server. So that's option that option is used to configure our DNS server. Now don't get intimidated by options. They are not difficult. It's actually very easy. I'll show you in the second half or even in your lab, the lab I'm going to give to you, you're going to see it. It's not difficult. Don't think of it as it's not a big thing. It's something very simple that you can do. You can do it within 2 seconds. You're done. So don't think that, option, it's something. No, it's not something big. Something you can do easily. Now, option 15, that's 015, is for domain name. If I want to include domain name in my deployment, like for example, if you hover your mouse on the network connection in the classroom, you're gonna notice that the option is if you hover, you're gonna notice that it tells you it should tell you the domain where it belongs to, as if option 15 is configured to tell you the domain that network belongs to. Okay. All right, we already talked about DSP reservations. We talked about reservations already. Um, how do we create reservations? It's not difficult. To create a reservation is actually very simple. So once you create your scope, you're gonna have options for reservation. You're gonna have the option for reservation. You're just gonna right click and select new reservation. Then once you open new reservation, it's gonna ask you for the IP address you want to reserve. You put the IP address, then it's gonna ask you for the MAC address of the device you want to reserve that IP for. So every reservation has to be tied to a MAC address. That's the thing about reservation. But exclusion doesn't need MAC address. But reservation has to be tied to a MAC address. Provide the MAC address, then automatically it's going to register that. It's going to register the reservation. So every time that device tries to request an IP address from the DSP server, it's always going to get the same IP address. Okay. Now, the next thing on my list is Super Scope. Woohoo! Super Scope. What are they? What are Super Scope? So, sometimes you might have a lot of scopes in your DHCP server. Basically, a super scope is a scope of scopes. So what does that mean? So we have, let's assume we have a couple of scopes. We have maybe 5, 10 scopes, and we want to create one scope that will, represent all the other scopes. I think in terms of management, so what we do, we create a super scope. So with super scope, we can support a very large subnet. Remember what I told you guys before? Every DSP scope is actually a subnet. So if we have several subnets and want to be able to manage them easily, we can create a super scope. We can create a super scope. So I said the super scope is it allows us to bundle several scopes together as one big scope, mostly for administrative management, right? So it's easier for us to manage all the scopes with just one scope. Okay. Now, to create a super scope is the same way we create a regular scope. Right click on our DHCP server. If it's IPv4, right click on v4 and create a new super scope. That's how we do that. So you're gonna click on create a new super scope. Then it's gonna ask you to select all the scopes you want to add to the super scope. You select all the scopes you want to add to the super scope, and while you give it a scope name, once you're done with that, click OK. Then it will create your super scope. All right. We can also create what we call a multicast scope. A multicast scope is a scope that issues out to a multicast address, right? Like multicasting is when when you send one to a group. That's multicasting. Now, multicast scope actually, hands out multicast addresses. That's what multicast scope is used for. To create a multicast scope is the same thing like regular scope. Like the same way we create regular scope. We're gonna right click on the IPv4 v6 and select create new multicast scope. It's gonna provide it a name and provide it a range, and that's it. It's gonna create the scope for you. All right. So now, what about IPv4, IPv6? All this while we're talking about IP version 4. What about IPv6? The way we implement IPv6 scope is similar to IPv4, but IPv6 is a different beast on its own. That's one thing you must understand. IPv6, the way you manage IP version 6 is a little bit different from v4, but is similar, but there are a lot of differences. To create an IPv6 scope is the same way we create IPv4 scope. Right click on the server. That's you're gonna right click IPv6. I'm gonna right click on IPv6 and and select create a new scope. Once you select create a new scope, the next thing you're gonna do is you're gonna ask for the scope name, just like we did for v4. It's gonna ask it for the range. Once you get all the range, you hit OK. The scope will be created. All right. Now last time we were talking about DHCP DNS policies, right? So just like with DNS policy, we also have DHCP policies. What are they? The policies define the way the DHCP server is going to operate. The way the DHCP server is going to behave, it's all tied around the DHCP policies. Now, so DHCP policy, like I said, it defines it defines how our DHCP server will behave. Basically, that's what it does. It defines how the DHCP server behaves, right? It allows us to uh, control our DHCP server up to the tiniest level. So, like we said here, it provides granular control, so up to the tiniest bit of control over how our DHCP server will behave and how it's going to assign IPs. Okay. Now, your DHCP policy. Um, so let's look at this example here. Say a DHCP policy can support the following scenario. Number one, if you have different type of clients, for example, you have desktop, laptop, and whatever. You want to assign different IP addresses to each of them, or want to put each of them in different subnets. You can use the DHCP policy to create it. For example, you have an IP phone and you have your computer all wired together in in series. Now you want the phone to be on the voice VLAN, which is probably in a different subnet, and you want the desktop to be on the regular data VLAN, which might be another subnet. With DSP policies, we can create that. So what we are doing in essence is we look at the MAC address. The MAC address can tell us what type of device it is, right? Or we look at the vendor. The vendor of the device can tell us what type of device it is. So based on that information, we can decide, okay, if it's a phone you're going to be on voice VLAN. So you're going to get this different IP address. So you can have two devices connected to the same line on the switch, but they have different IP addresses and different subnets. The way we can do that, like I said, is through the DHCP policy. The policy will help us to do all of that. Look at another scenario here. If you want to have a mix of wired and mobile computers, you can assign short list duration to mobile computers, longer list to wired. Yeah, that's another option. Like I want my mobile devices, maybe let's assume if my default list period is 8 days. And that list period will be for any device that's hardwired to the network. I can also decide that, you know what, if you are not hardwired, if you're connecting through the wireless network, your IP list is gonna be for maybe 2 days. Okay, good. I've been mentioning list. What is list? It's just the same. It's the same meaning as the English word list. Now, when a DHCP server assigns an IP address to a client or to a host, that IP address is not permanent. It's temporary. Okay, any address a DHCP server assigns to a host is temporary. It's not permanent. Now, what usually happens is this. Most IP lists is usually for 8 days. Now, usually before the 8 days period elapse, maybe I'll say around 75% into the list period, the DSP client will message the DSP server that, hey, by the way, I have this IP address. My lease is going to expire on this time. Can I renew my lease ahead of time? Or can I keep this IP address after the lease expires? I mean, I want to renew this IP address after my lease period expires. If the DSP server, check and everything is okay, the DSP server will tell the client, oh yeah, sure, you can keep this address after it expires. So automatically, once the lease expires, it's automatically renewed for another period. So if it's 8 days list, it's going to renew for another 8 days period. That's the way it is. So any IP address that DHCP assigns to a client, understand that it is not permanent unless it's a reserved IP. If the IP is not reserved, it is not permanent. So that's why sometimes you can log in this morning and you have an IP address and you go back, you log out 2 hours again, you come back and log in. You notice that you get a new IP because the IP that this person assigns to you is not permanent. That's why it's called dynamic because it's always changing, right? So and the change is based on number one factor, the lease period. Oh, there's something on the screen here. The lease period determines how often that is going to change. Um, so, like I just gave you another example of when you're going to use DSP policies. Maybe you want to assign different lists for different devices. You can also do that too with DSCP policy. So you see, there are a lot of things that we can do with DSCP policy. But how do we create a DSCP policy? Now we can create a DSP policy different ways, but one of the easiest things to do before creating a policy is to create what we call a vendor class. What's a vendor class? The vendor class is going to help us to identify devices that belongs to a particular vendor. So if I want, for example, the first scenario I gave there, if I want to assign IP address to different devices. Let's assume like I said, I want a desktop phone, IP phone. I connect the IP phone to the computer, I connect them in series. I want to assign the IP phone to a voice subnet and the desktop to a data subnet. How will I be able to know that this is an IP phone and this is a desktop? I can create what we call the vendor class. The vendor class is just going to be a way to pull information about maybe the hardware address, the MAC address, and look it up to find out what type of device it is from vendor. Every MAC address has two parts. I don't know if you know that, but it has two parts. The first part identifies the vendor, and the last part identifies the device. It's just like IP address. The first portion of IP address identifies the network, the other part identifies the host. It's same with your MAC address. The MAC address identifies the vendor, meaning that who is one and manufacture it, and also what type of device it is. The other part is just for the device itself. So that's how you know. Oh, if you see a MAC address, you know what type of device it is from the vendor information. From vendor, I can know what type of device it is. I know who the vendor is. I know what type of device it is that I'm dealing with. Okay. So the first things first is to define, create a vendor class just to identify devices and to know what a device is and what it's used for, basically. Okay. In this example here, we are defining. We're trying to define an IP phone called Norton. So Norton I 2004A. We're trying to create a vendor class for that. And also we also created a vendor class for a printer. So you're gonna define what you're gonna so we use vendor class to define what a device is and what based on their physical address. Basically, any device that communicates on the network has a physical address, which is the same thing as a MAC address. Okay, so we can also create, like I said, we can create a scope policy. So the same way we actually create our vendor class, we can create a scope policy. The policy is going to help us to manage the scope. We can, like I said, we can assign a scope. So once you define your vendor class, you can create a scope policy. The scope policy will now assign IP address based on the vendor information from the vendor class, right? Same like I was telling you with the IP phone. If it's an IP phone, I know it's an IP phone, so I'm going to assign it address based on this scope. If it's a desktop computer or a laptop, I know it's a computer, then I'm going to assign it address based on a particular scope. You can even take it further to add it to assign IP to different IPs to laptop, different IPs to desktop, different IPs to mobile devices. It's totally up to you. But it's just an option that is available to you with DHCP policies. Okay. Um, Now earlier I was telling you guys about DNS automatically, configuring the DHCP automatically configuring DNS. And how do you do that? First, you have to make sure you register, create a registration for your D for yeah for DHCP in DNS. So once you do that, what happens is that whenever the DHCP server assigns an IP address, it automatically updates that IP address in DNS. I said every time a DHCP server assigns an IP address to a client, usually what happens is that it registers that address in DNS. Why? So that we have an up to date information about the host. Okay. Now, when we configure DNS registration in DHCP, what we're doing is so every time an IP is assigned to a host, DHCP is going to enter the FQDN of that host and the corresponding IP address in DNS. Like you're going to see when you do your lab, if you create a dummy host and you assign that dummy host, or that dummy host gets an IP address through DHCP, if you go to your DNS server, you're going to notice that that IP address is registered in DNS. DHCP does that for you. It does that for you automatically. Okay, you can also create policies that also specifies how the name will be registered in DNS. If you want to change the suffix or you want to add something to it or whatever it is, you can do that using DSCP policies. Okay. All right. The next thing we are going to look at right now is um, to configure that policy. Um, to configure a policy based on the FQDN. You know what FQDN is? Fully qualified domain name, right? How do you do that? So under your DSP server, if it's IPv4, IPv6, whatever you do, you're gonna expand the scope that you just created. Once you expand the scope, there'll be a node under it called policies. So from that policies, you can right click on it and create whatever policy you want to create. Okay. Um, for example, in this example we have here, we want to attach a datum.com to every host name, right? And how do you do that? You're going to use a wildcard bit. So use a wildcard bit. We can add the asterisk. So we put the domain name, and we're going to put asterisk means that every host. So every host will assign an IP address. When we want to register it in DNS, we're going to attach uh, the host name dot addendum, and that's for this example here. So we're attaching a domain name to a host name before we register that in DNS. That's what we're doing with this policy. Okay. Now the other popular use, earlier I told you that DHCP is also your DHCP actually gets its mode of operation through boot P. So the modality of operation is exactly the same way boot P server works. Now, having said that, I told you the last time that we can configure uh, our deployment server through DHCP. But how do we do that? We do that through DHCP option. Now, in order for you to be able to actually boot a device remotely and even load operating system to it, you need what we call, so that device, the network adapter has to support what we call PXC. If it doesn't support PXC, there is no way we can load our our boot screen from the network. So your network adapter must support PXC. Now, apart from PXC, on your DSP server side, There are three options. Yeah, no, not three options. Actually, a couple of options we need to configure. The first option we need to configure is option 60. Okay. Now, the option 60 allows your device to be able to discover uh, the DHCP server to get the address of the boot server. So once you configure option 60, the next option you configure in DHCP is option 67 and 68. Now, what are those? Now, the option 67 and 68. So 68 is it will allow the DSP server to respond to the client with an address for the boot server, right? And the other one is 66. 66 is actually so 66 and so well 66 option 66 also is how the client will discover the boot server. What is the name of the boot server? So the name of the boot server will be option 66. And also 67 will tell the client where to get the boot file from. You know the boot server, but what about the boot file? Where is it located? Option 67 will tell the client where the boot files are located. So the client will go and load the boot file from the location and load the system automatically. So if I want to configure all these computers, I want to install Windows 10 or Windows 11, all these computers, uh, I'll use a WDS one. Now, what WDS used to be something I used to add to the syllabus when I'm teaching it. That used to be the last thing I teach, but I took it out. Why? Because Microsoft has actually stopped supporting. Well, Microsoft actually took out WDS from Windows Server. There are other tools to deploy Windows. There are other tools not to deploy your Windows operating system. You have tools like SCCM. SCCM does the same job. So, and that's why I stopped teaching WDS. But WDS is actually a tool that can help you to deploy softwares and operating system to clients, without you doing anything. But unfortunately, Microsoft has taken it away from Windows Server, so I can't teach you. Even if I want to teach you, it's gonna be I can teach you, but it's gonna be a little bit harder because I myself I've never sat down to even look at what is the options. If I need to download the BDS separately, or if I can download it separately. But it used to be part of Windows Server, but not anymore. But just understand that if you are going to create a deployment server, even if you're using SCC, I think SCCM, I can't remember now if it's in the configure, but if you're going to deploy a Windows deployment server, you need to configure option 60, 67, 68, and 66 on your DSP server. Okay, and the last thing I want to talk about today before I wrap up is your relay agents. Now, this shouldn't be new to you. This is the same thing as what we talked about in what we talked about in networking. Now, what is relay agent? Now, we understand that when we have yes,
Sir, for PXE boot, we have to configure all the options to data network server driver or just one option.
it depends on your environment, but for sure, option 60 needs to be configured. Option 67 has to be configured.
60, 67.
Yeah, and you can configure 66. Yeah, 66 is compulsory.
So it is configured with the help of IP address only.
No, there are
It's
options. Once you create your scope, you're gonna go in. You expand the scope, and you can add options to it. Like we're gonna see when we start up the server. So once you create the scope, once you expand the scope, you're gonna see like a folder under it for options. You can configure these few options there, or You can even right click on the scope you just created and select options. Then from the options you can now add those options. Like I told you, adding options to a scope is not difficult. It's a 2 second stuff. So all you need is just right click, select options, tell it what option. So the option number is important because the option number is like is like what ties into that option. Like if I want to configure DNS, I will not see DNS in the options. I need to enter 003 to tell that I want to configure. No, I said not the, that's the default gateway. That's router address. So the router address, I need to enter option number 003 or enter option 3. So in the option number, I'm going to put 3 or 003. Then I'll put the IP address of the router, which is my gateway, or the IP address of my gateway. So you're not going to see, oh, router, I know. You have to enter the option number. So you need to know what the option number is. For default gateway, it is 003. I think for DNS, is it 005 or something? I don't know what it is, but I think 005 for DNS. So you need to enter the option number and enter the address. So for the same thing for you want to configure your boot server, or you want to configure the deployment server, you need to enter the option 60, put the value options, yeah, just like that. That's what it is. Now, routers will not allow broadcast, right? And it's going to be a big problem if you have a router sitting in between your DHCP server and your client. You know, the way DHCP version 4 works, it works through broadcast, right? So the client will send the broadcast. Okay, you know what? Let's just talk about that. Then I'm going to wrap up the whole thing because this is the last one I'll talk about. Let's quickly look at how DHCP, let's look at the way DHCP works. I want to explain that in 2 minutes. Now, let's assume this is client A. It needs an IP address and it connects to a network. And that's the DHCP server over there on somewhere on the network. What the way it works is the first thing that happens is that this client is going to send a broadcast out on the network that I need an IP address. Is there a DSP server available to assign me an IP address? Now, if there are more than one DSP server on the network, all DSP server will respond. Now, let's start with the first message. The first message, which is a broadcast message that the client sends out to look for a DHCP server, is called a DHCP discover message.
It's kind of Dora. Discover.
Yeah,
What?
it's actually Dora. DHCP discover message. Now, once the client sends a DHCP discover message, which is a broadcast, every DHCP server that hears that message will reply to the client with a unicast message. And what do they do? They will send an offer. That's DHCP offer. So the server will send a message to the client, hey, Mr. Client, you need an IP address. Okay, I have this configuration. Take a look at it. The client will look at it, and if the client likes it, because like I said, there's so many all the data will send the client a message. The client will now request to keep that IP address. And that message is called a DHCP request. So from the client back to the DHCP server is a request. Mind you, I said there are so many uh, configurations that the client might receive from different DHCP servers. But the one it needs is going to send it to the DHCP server. Hey, can I give this IP address? The DHCP server will not check. Okay. Has someone else already taken that IP address that you are requesting? If nobody has taken it, then the server will send back to the client and acknowledge it. Oh yes, you can keep his IP address. And that's the way it works. But this is the problem. The initial message is a broadcast. Routers do not like broadcasts. Routers will kill broadcasts from the source. As it's coming, it just kills it. Well, how do you now get your client's DHCP message across to the server? We need what we call a relay agent. Relay agent, or sometimes called DHCP helper address. Now, the DHCP relay agent, what it does basically is that it takes that client's initial broadcast message and send it to the DHCP server that we configured as a unicast message, because it knows that the router will not allow broadcast. So it takes the message and sends it out as a unicast message. Okay, so once the DHCP server gets that message, then it can reply back to the client, and all the other conversation will happen from there. All right. So this is where I draw the curtain on this subject.